Okay, everybody, good morning. It's Friday morning and the 15th of September, and been out already this morning, out to see a client, and it's about 9 o'clock in the morning, and came back over here to the office to do a recording. This is a supplemental recording for BISS 1123, business problem analysis. And I was out there this morning, met my client. We had a 5:30 meeting, a little early, but we got some good things done. And as I came on back over to the office here in Oklahoma City, I really noticed what a wonderful, beautiful day it is. The wind has that nice fall, that crisp fall tinge to it, beautiful clouds. And I was thinking, what a wonderful privilege it is for all of us to get to study business. What a wonderful privilege to be in college. You know, there's just a very small fraction of people in the entire world, comprised of 7 billion people, who get that privilege. And I also wanted to let you know, I hope that you will enjoy your time. I know that you get pushed and stressed. I feel like we overschedule you. Your parents probably did the same thing, too much soccer, too much this, too much that, and you don't get a chance to reflect on college. And you don't get a chance to reflect on your life. And as educated people, it's important that you live a life where you reflect on that life. And I can assure you that your time on Bison Hill is going to be among the best times of your entire life. I know there's pressure and there's stress. There's also great opportunities to learn about yourself, to make some lifetime friends. I have one of my dearest lifetime friends was my roommate over there in the 3rd floor of the men's dorm. Yep, right over there. I know that area well. And it has always been for me one of those amazing things is I've met people who went to school there, or as I go to class reunions. So many of my friends here, I grew up in Oklahoma City, went to OBU, and what a wonderful time it was there. We had a great time, but we worked awfully hard, and we worked very diligent with our studies. So I want to tell you, and I do appreciate that. I appreciate that many of you are working, or you have scholarships. And so I wanted to tell you that I know this is a little bit different format, but I encourage you to embrace it. And I encourage you to embrace it for 2 reasons. One, this gives you an opportunity to control your time and maximize your time. And number 2, it gives you an opportunity to see what it's like to work in a global company. Because if you go to work for a firm that's global in nature, you will be working with people in different time zones. You'll be working, you may have your home office in another city. My wife worked for FedEx for a long time, as I mentioned. And Julie she worked in the sales office, and she was in sales support, and her unit was there in St. Louis. If you know St. Louis, she was right across the Missouri River, right over what's called St. Charles, and right there off of Interstate 70. And she had a boss in Memphis. She had a boss up in Minneapolis, Minnesota, and they conducted virtual meetings all of the time using the technology that was available then. And so this is also a good chance for you to get acclimated to that, because it will become the way of the world. And I do want to take these opportunities at times to reflect. And I know I joke around a lot, you know, and sometimes I might bark a little bit. But I want you to know how much of a wonderful privilege it is to me to be with you. And I never dreamed I'd be back at OBU. Frankly, I never really wanted to be a college professor, but the good Lord, I guess, had plans for me. And so here I am. And maybe it's to punish you. I don't know, but we're moving into an era where businesses moving at an unprecedented rate, and we're seeing whole industries emerge. We have industries like social media. People didn't even have a sense of what those would be. And I can tell you that, you know, when I sent my first email in 1978. That's the truth. I worked on what was the originator of the internet. It was called DARPANET, the Defense Advanced Research and Programming Administration. And DARPA was set up as an underground phone system and communication system that was to be used in the event of a nuclear war. And I sent my first email. I'm using a modem that was about as big as half the size of a desk, and it took 45 minutes. Of course, today that's all changed in the internet, and then the development of web pages have just changed everything. So I've been along for the ride with this thing and seen it unfold. And so all I can say is that things will change so dramatically for all of you as you go through your career. And I hope that many of you will take a look at using your skills for good. You know, we have a social entrepreneurship program at OBU, and I'm really struck by, I think, what to me would probably be the most challenging and exciting work that one could do, and that is disaster recovery. And I think that, you know, there's going to be some opportunities for some of you if you have a heart for people. And I worked disaster relief a few times when I was in the service, and I can tell you that people really truly respond to that. Well, I've waxed a little bit too philosophical, but I'm sure that some of you today had that wonderful experience. I know this morning I was with my client, and we were out, I guess, about 6:30 in the morning. I had to be over there about 5:40, but meeting 5:30, and then we met for a while, and it had that wonderful fall, and that wonderful time. And of course now it's about 9 o'clock, 9:15, and I'm back here, and then I got a couple of more places to go this afternoon to do some work. So trying to get some recording done. And I do appreciate the fact that this is a little bit different, but let me say this. I think you would want to have a professor who's out there working with people in business, who is staying current, not only just in terms of reading the newest books or reading the latest journals, but actually out there with business people and people in different situations who need business skills. And so I do that, and I want you to know I do it for free. I do it as a way to promote the institution. I do it as a way to serve people and to share the knowledge that I have. Well, enough about that. All I can say is when I stepped outside this morning, I thought, man, we're getting to the point where it's time to go duck hunting. And I don't duck hunt anymore. I used to, but stopped. You know, those of you who may be hunters, enjoy your time. It is that point of time. And for those of you who just enjoy nature, fall is a wonderful time of year, and I hope you'll enjoy it. And so I wanted to share that with you. I am a human being, you know, just like all of you are. I have a life, and I like to share with you because I've been where you were. I sat in those seats a long time ago. I went to chapel. I had all the stuff you have to deal with. We just didn't have the technology, but we had a lot of the same kinds of pressures. We had a lot of the same types of opportunities, and I hope that you'll use it as a chance to make some lifetime friends and to enjoy yourself. And one of the things I've noticed about your generation, and mine was some of the same. Mine was in many ways the same way, a little bit cynical. You know, I was a very cynical person for a long time, and I still retain a lot of cynicism. But I've also learned that, you know, there's the person who knows the price of everything, but the value of nothing. And I've had to, at times, recalibrate my attitude, recalibrate my thought processes. And I think the guiding light for me, other than the good Lord and His Word, has been my parents, who were both entrepreneurs. So I grew up in a household where business was on everybody's lips, and how we do things and run things. I know that my parents were never ever focused on money. They were always focused on what they did for people. And so that kind of helps me recalibrate and get back. And I want to say that I consider it a great privilege to be with all of you. Sometimes it probably doesn't sound like it. I bark at you a little bit. That's because I love you and I care for you. I want you to do well. And I understand many of the paths that you'll go down. I wanted to share that with you because I just felt that was on my heart, and I needed to share it with you. I didn't need to tell you how bad you are or how lazy you are or what you haven't done lately for anybody. I think you have some wonderful opportunities that I will never get to have, but I've had some wonderful opportunities my parents never got to have, and they help make the world a better place for me. And if my encouragement of you today helps make things a little better, I hope it does. And I want you to know that I do truly appreciate the privilege of being with you, and I hope that you will do yourself a favor and me a favor. I'd like you to take an opportunity and go over. I'm over here at the course, okay? And I'd like you to go into my syllabus and take a look at what I've had an opportunity to do, and the roads I've got to travel. I've had some pretty interesting and good experiences, and I've done that because of education. I've done that because I had the Lord sent people my way who were mentors at different times, and so I suppose I came back here and ended up back here as a way to pay back what was given to me. When I went off to college, I had been a pretty good student, and I had a great dream. My dream was to play catcher for the New York Yankees, and that was my dream. And I was a good catcher. I hit very well. I could field. But when the scouts came to see me, I didn't have the arm strength to throw the ball to second base as fast as they wanted. And so that was the end of that, okay? And I thought at that point, my life's over. And a lousy thing to happen. But I learned a very important lesson. That is, it's a cliche, I know. When one door closes, another door opens. And I headed off to college. And I hit the Civ courses, and my mind opened up, and I said, there's a whole world out there, a whole lot bigger. And that was a great gift. It was given to me by the school, so maybe I'm repaying it back a bit. I'm not sure. Wanted to share that with you to just kind of put things in perspective. What you hear behind me is not a reindeer. That's my dog. Our dog's a rescue dog, and she's a snicker doodle, or schnauzer doodle, whatever you call it. She's a mix, but we got her from rescue, and she's an interesting little character. That's all I'm going to say. All right, folks, let's get to work. Enough of that. Last night, and I recorded this, we covered case number 8, spreadsheet case 8. We talked about Action Plastics. And in that case, once you review the video, you're going to see that we made an extensive use of conditional statements. And we used a nested conditional statement as we developed that little spreadsheet, or kind of the start of a dashboard for those insurance costs. And we worked through that process of, the premium and how much the employee paid, how much the employer paid, that business. And so that was a way to get us started in looking at that type of activity. And so we worked through case number 8, spreadsheet case 8, Action Plastics, and we did that last night. And that was pages 76 through 79. Now, last night I also did just a short overview of the case Karma Digital, okay? And we're gonna work with it for just a second, and save this for a second. The Karma Digital is a case that helps us look at, and we're getting our feet wet working with linear regression. And I went through a PowerPoint that talked about the XY relationship and all of those types of relationships, those linear relationships that are out there in business. And one of the things that's important about that case is that you start to understand data. Many times data come at us in predictable patterns, and the data will tell us a story if we let it. And and we're always using data for decision making. So we're going to take a look at that. And I won't go back over the PowerPoint. I went over it. It's over at the Supplemental website. So I'm going to click on the module on the syllabus part, syllabus section. You'll notice we're working way ahead, and we always do. And people get a little confused or bemused by that sometimes. And I'm going to tell you why we do. When we get over to the point where we start to work on the access cases, we will slow down considerably, because I found that most of you are pretty comfortable working with a spreadsheet. You pick it up fast, but I don't know that you have much of an understanding or knowledge of databases. And I want to lay that foundation for you. And I think it's important that we do that. I'm going to go back up here for just a minute to the modules section, okay? And we'll come down here to the, I think I had included that for you. And we'll take a look here just a second. Again, you're getting to look at everything that I have there. And we are going to have some fun in terms of working with those database cases. Now, that being said, okay, this is a little PDF on business data roles, and I want to open it up and download it. This was put together by a guy who's a professor over at Duke University, Dan Egger, and he has studied what we call now data science. And I've gone through, I went through a certification program in data science over at Johns Hopkins University a couple of years ago. Yes, I actually take classes and try to stay current. And I want to zoom up because I want to show you something. Now, when he talks about business data roles and companies, and I'm going to go to the full screen on this so you can see it, and then zoom it in a little more. You're going to see, okay, what we call the job title of the business analyst. Okay? And by the time you leave, okay, you will have had some experience as a business analyst. In other words, you're going to leave here with those skills. Okay? In fact, actually, you leave with the skills of a business data analyst if you take all the BISS courses. And these courses are designed to prepare you for this world where people compete on analytics. And when you get to the business policy course, we'll talk about it, what that means. But we give you the tools to work as a business analyst. Okay, now you're really not a data scientist because there's some other things that you can see that they have, okay, and that they learn. And this gives you some of the relative demand for those folks. And you can see what makes you what gives you a real distinctive is not only that you have marketing concentration or you're in accounting or whatever, but you have these skills. By the time you leave, you'll have them. This is going to make you a very valuable employee. So you'll be able to sit down and say, yeah, I'm comfortable with spreadsheets. Yes, I understand databases. I've worked with them. I understand what a data warehouse is about. And when you begin to communicate that with a lawyer, communicate that with an employer, it's going to be for you a wonderful, you're going to be viewed as somebody who has some value to bring to the company. So I'll exit the screen. So I wanted to give you that so you can see that there's a method to our madness. And Dr. Egger has done a lot of work with companies trying to figure out what is it that you need in terms of technical skills, what do you, and so when you leave, you'll have the skills of a business analyst. Not bad at all, my friends. Not bad at all. So there is some value in taking this course, and the fitness and the fitness information technology course, the data admin course, and MIS. They all fit together, and they all get you prepared for a world where technology dominates everything. And that's just how things are. And we want you to be prepared. Okay, let's go back again to the syllabus part. And as you can see, we are working ahead quite a bit. And we worked on, last night we worked on case number 8. Today we're going to work on case number 9, which is Karma Digital. So click on the Files section, okay? And you'll come down and let's find the solver student files. Now I think I'm pretty sure I have the key down here for XLS 9. Yep, I published it there. Okay, so you have it to review, but we're going to tinker around with it a little bit today, and we'll go up and we'll go to the solvent student files. Okay, and you're seeing some things that let me go up to settings and change this so I don't confuse you with a bunch of stuff. So I'll go here to the student view. There we go. We'll go back now to files. And we'll come down to the solvent student files. There they are. Click on it, we'll download it, zip file. And we'll look in here and there's Karma Digital. So I'm going to diminish my browser and I'm going to take Karma Digital and put it on my very nasty, very crowded desktop. Okay, close that off. Let's find Karma Digital here, wherever it ended up. It's here somewhere. There it is. right by Cardinal Blue. Hey, Cardinal Blue says, good morning, everybody. He's happy. The Cards won last night. All righty. Here we go. A Karma Digital, and I've given you enough information about XY data and looking to the relationship among data that have that characteristic. I think it's important that you learn how to look at a table of data, because you're going to be getting tables of data all the time in one shape or form, sort of fashion, and look for patterns, okay? And as you look at this, you could see this is a company that makes DVDs, and Karma Digital is over on page 81. And you can see a very consistent pattern. Their production volume is going up, okay? And their percent defective is going up. So what's happening here is that the more stuff they make, the more defective products they make. So they have a problem. It's called a quality control problem. And we know this, that if you have a dissatisfied customer, that person will typically tell somewhere between 20 and 25 other people. It's far about their bad experience. It's far more difficult to get new customers than it is to keep the ones you have. Well, they ask us to do some work here in Karma Digital, and they give us some information about the company, and that's all over on page 81. And again, they give you some more information, and at the bottom they start to give you the word problem about how many of these things they've made and all this business. And I've gone over the Cartesian plane, the ordinate, the abscissa, have talked about that. And there on page 82, the authors say, we can do a regression analysis as a means to predict where this might end up if we continue doing business as we are. Okay, and then that gets us to the tasks, excuse me, at the bottom of page 82. Okay, now I want to show you something. I'm going to click on data. Okay, and you'll see that I have a thing called the data analysis tool. If you don't have it on your machine, okay, you're going to need to click File, Options, okay, then Add-ins, okay, to the options. There we go. Now you can see that on my machine, I've added the analysis tool pack. If it's down here in actives, just press that and then press go and it'll be created. Okay? So you have to make sure you have the data analysis tool pack. I want to click on this and show you something. Excel is a superb product in that it has some of the better data analysis tools. This is not a course in statistics by any means, but it does have some tools that we can use, and the one we're going to be using is the linear regression. Okay, now the bottom of page 82, they start with 4 tasks, and make sure you have the analysis tool pack. Okay, now you're going to see some things that I want to remind you of. One of the things you're probably going to see in this case is scientific notation. You may see something, for example, that says 1.23 E as an eagle plus O3. That equals 1,230. Okay. You might see something that says 1.23 E as an eagle minus O3. That means 0.00123. The scientific notation allows us to simplify and save space in terms of dealing with high digit numbers. Okay, Just wanted to get you on top of that. Now, there's another thing that's operating here, and one of these that we talked about yesterday is the slope. And we use the slope to look at, to build regression, and that is the rise over the run. And the rise is the new value minus the old value. And that's divided again. That's the increase in the y-axis divided minus the prior value, and then the current value in the x-axis minus the former data. And we're going to use basically we're using the y plus mxb, where x is the observation, m is the slope, and y is the intercept. So we're using we're using the model of a straight line to test our data, and we're going to build that model, and then we're going to say, okay, the data, and we're going to put those data points out there and say how closely or not do they cluster around that, what we call the line of best fit. So we're going to create a column here called the regression line. Okay, you'll notice the pre-formatting is there, so I'm going to click up here for a minute on home and wrap the text, smudge over a little bit. So I have the regression line. Okay, so they tell us to do that. Now, they tell us to the right of the column, we're going to create the regression line, that's number 2, and then multiply the value of the x variable 1. In other words, production. We have 2 variables here. Production is the x variable, horizontal. Percent defective is the y variable. Okay, it's going to tell us to take the production volume, i.e. the independent variable, that production volume, and add it to the value of the constant. Okay, and we're going to apply it as cell reference and so forth. So to give us all these things to do in number 2. Now, come over here to about, I would say column J, all right, and click on data, and click on data analysis, and we're going to look for regression. We'll click OK, and that's going to bring us to the regression dialog box. Now, it wants the y input, and the y input is going to be the percent defective. Okay? So I'm going to click on the cell grabber, and I'm going to get the percent defective. Okay? Then I'm going to get the production volume. And you'll notice in this skeleton file, we only go up to 2008. That's because they want us to do some predictions out to 2009 and 2010. Okay? Now, we have some labels, okay? And we don't have those, all right? And then we want to run this, and we have some choices. We can put the output range there in that cell, in that worksheet, or in another worksheet. And I'm going to click output range. And we'll click here at K3. Okay. And I'm going to get the residuals. And I'm going to also choose the line fit plot. The residuals is literally the difference between the actual value and the predicted value. That's all that is. Okay. I'm going to click the confidence level. Put that at 95%. And we're ready to click OK, and let's see what we get. And there is our summary output for the regression statistic. Now, I want to show you something. I'm going to slide over here for a minute, and we had asked for a line fit plot. Okay, turn that up a little bit. This lets you, you're not going to break it if you don't, but you do want to be able to see. And here is y, in other words, the actual value, and here's what's predicted. And I'm going to click inside here, and I'm going to click, let me see how much to, I want to add a line there. Click on one of the red squares. But before I watch, it'll give us a pop-up of what it is. This is predicted. Here's the actual. Remember I talked about that line of best fit. So I'm going to click in the red line here, and I'm going to click Add Trend Line. And we assume these data are linear, okay? And we're not going to do any forecasting. We are going to set the intercept at 0, and we'll close it. Now, you see the straight line, you see the predicted data, and that line of best fit, that little line, is a model. And when you do regression analysis or correlation coefficient, imagine that rather than having a line here and having a bell curve, you have a line that goes diagonally here, and you have a series of bell curves. And we want to see how tightly does everything cluster around that line. The tighter the cluster, the higher the correlation, okay? And so regression analysis lets us say, okay, how are we looking? Now you'll notice that the predicted y, that's the red square, okay? That predicted y is pretty close. And then you see the actual values, that's y, okay? And you'll see that for all, you have a couple of kind of outliers, but otherwise it hugs pretty tightly. Now we're going to see some mathematical or statistical expressions of that over here in the summary statistics. And just to make it a little bit easier to read, I'm going to go ahead and make them, I'm going to click home, and I'm going to make them bold, okay? And I'm going to do the same with these others. And I'm going to move this over a little bit so I can see what I got, okay? And you'll notice I'm just doing a little bit of that. Okay. Now let's talk about the summary output. Let me bold that. Okay. We have the multiple R, the R square, and the adjusted R. Now the R square is the one statistic that, in my mind, tells us the most. R square is the correlation coefficient. If you've had stat, this will make sense. The correlation coefficient squared. What it does is it says what % of variability in the data is accounted for by this comparison. All data have, every bit of data has two qualities, two pieces. One, what we call the signal, and the other is the noise. And think of it like if you're dialing the radio, and you don't get this in FM, but if you go to AM, you dial and you'll get a lot of crackling and popping and that kind of thing. That's noise. And then you find the AM station that you want to listen to. That's signal. All data have signal and noise. And what they're saying is that we can account for, roughly, we can account for about 89% of the variability. 11% of it we can't account for. This is pretty high. And it's pretty high given the fact that we have only 10 observations. Okay? So that first piece. Now the next is the analysis of variance, and that's a little bit more complex thing, a little beyond the scope of this course. But we do come down to a key part that deal with the intercept, the coefficients, standard error, the t-statistic, p-value, etc. Now, I'm going to go ahead and I'm going to put that in a box. And then I'm going to come down here to the residual output, and we're going to take a look at it for a moment. Okay? The residual output is pretty simple. It says, okay, what did you predict? Okay? And what's the residual? And if you take this value minus this value, you'll get the value for period 1. And if you look up here, you're going to see about 1.5. So I'm just going to do this. I'm going to take this equal minus and then we have that residual. Actually, I see what I did here. Okay. And I need to put this as an absolute value. So I'll put ABS, my mistake there. But I thought that didn't look right. Still doesn't look right. That's strange. Okay, that should be a 1.5. I don't want to get that weirdness. Well, let's just do this. The predicted value is 1.877. And the effective and the actual was 1.500. And we'll put this in parentheses. And we'll do the auto sum. And there we go. The 3.7. So now, obviously, the smaller the residual, the closer you have the prediction to the actual. Okay? And so that's the first bit of output that we get. All right? And we're interested in the intercept and the X1 value. Now, we created this value over here in the regression line. Okay? And so they tell us there, and then this is in the middle of page 83, multiply the value of X variable 1. Okay? By each value of the independent variables pieces produced, and then add the constant. Well, I'm going to click on this. I'm going to go up here to our friend, the name manager. I click new, and it's going to say X variable 1, and it refers to L20. Click OK. I'm going to click new, and here I'm going to find the cell in Q19, and the name of that will be intercept. Okay. And so we have the intercept, and we have the X variable 1. Now, what I'm going to do here is I'm going to click on this, and I'm going to edit this. And X variable 1 is actually the production volume. So I'm going to change the name to production volume. Underscore volume. And I'm going to click OK. And I'll smudge this out just a bit and close it off. Okay. Now, we're ready to go over here to the regression line. And this will equal, comma, and I'm going to click using a formula, the production volume, and that's going to be that coefficient times production volume. I want to back out of this for a minute. I want to do this right. I'm not comfortable with what I got. So I'm going to click up here in the name manager. And I'm going to edit that. I'm going to call it the production volume underscore coefficient. And when you hear the word correlation, if you take that word apart, it says correlate or correlate. That's the core of it. And so you notice we have a coefficient. Okay. All right. Now, I think we're about ready. Close this off. And we're going to do the regression line. And this is going to equal, and we're going to use a formula, the production volume coefficient, okay, times, I get this production volume, and I'm going to make that be 10, and so it's going to equal this product, okay, plus the intercept. Okay, and there's our first prediction. And then we just drag and drop it. Now what we've done is we've just used the equation for a straight line to build that linear model. Okay, and we'll go back here. Here's this line of best fit. Here are the predictions. Here are the actual values. The predictions are the red squares. The actual values are the little diamonds. You said, why don't the red ones just fall along? Well, this one does right here. And that midpoint sets everything. And it's interesting. Notice the pattern here. We're a little high. We're a little bit above. And here, the further out we go, okay, we tend to get, things get closer here because there's a pattern that's been established, and that is the more stuff we make, the more junk we make. Okay? Now I'm going to go ahead and make this a 2. We're just going to take it by 1 decimal point. So I'm going to click Home, Copy, Format Painter, and I'm going to, and then I'll go ahead and I'm going to put them in the middle so they stand out. I'm going to do the same thing with the percent effective. Okay. And so now we have made predictions. Now the nice thing is we have the actual data versus the prediction. Okay. And this table down here, this residual output showed us. And if you look down here at the 10th data period, the predicted value was 4.4. There it is. And that was less than the actual percent effective. So we're getting a sense of how accurate this is. But now we can do some prediction. Okay. And so we're 2009. Okay. And the authors, and we'll put that, make sure it's aligned right, it should be. The authors tell us that for 2009, we're going to produce 15 million. Okay. And I'm going to drag this on down. Okay. And we're going to stick with that prediction value. And then for 2010, okay, I'll make that straight. And this will be 20,000. And 20 million, excuse me. Okay. Now remember, we're making a prediction. All right. Now, if I wanted to, I could say, well, how much are these going up each year on average? And if we say, well, you know, it's going up about 0.4. There's some times here where it stays constant right here. So I'm not all that uncomfortable with these three constants, but I could say, well, in this period of time, it went up 0.3. So I can make that a 0.9 if I want. Oh, pardon me, that's 4.6. I can come down here for the 2009 and make that 4.9. And then I can make this 5.2 if I want to. Okay. Remember, these values right here are predicted. We know that we're going to make 15 million and 20 million. We're given. And so we kind of take a guess and say, well, it went up 4. It's been got 3 or 4. 0.34, 0.3 or 0.4. So I've got my regression line. Okay. Now the authors want us to chart this. Okay. And for all intents and purposes, it really is. Okay. But we're going to go ahead and do that just so we can see it. Now, I'm going to click on Insert. And we're going to do a scatter chart. And they want us to do a scatter diagram. Now we're going to get the data. We'll select the data. And for the legend series, I'm going to start with the percent defective. So the series name will be percent defective. And the series X values will be these. Excuse me. And then the series Y values, okay, that will be the percent. The series X values will be the production volume. I'm sorry, folks. The production volume. Yikes. And then for the Y series, I'm going to get the percent defective. Okay. I'll click OK. Now we're going to add some more data. And this time it's going to be, that's the legend series. And we have the, well, we have the X values right there. Click OK. And that series 2 let's rename, let's click on it and edit it. And we're going to call that the percent. We've got the percent defective, series X values, and the series Y values. So we're good there. Okay. Now, I've got my chart here, and I'm not going to burn anything up. And I'm going to take my chart, and I'm just going to kind of resize it. Don't worry about covering up the other stuff. All right. We've got series 2. Now I'm going to click in here. Okay. And I'm going to click on one of these, and I'm going to add a trend line, linear, and close it. And then I'm going to also, on that trend line, and that's the linear percent defective. And then we have series 2, which is the, of course, the predicted value. So if we look at this, okay, we'll select the data for series 2. I can edit that. And that's predicted. Let's skip that. We don't need that. Good enough. But this shows you again, and we'll format the trend line with linear, and we'll put that at set the intercept at 0. And we're going to display the equation on the chart and the R squared. There's our R squared. And this shows us the pattern, okay? And what this is telling us is the more stuff we make, you know, the higher the defective level. So we have a problem that we have to deal with, okay? Well, that, my friends, is Karma Digital. That's case XOS case number 9, and there's a lot there, but I think we're in good shape. So what I'm going to do is I'm going to take this chart, I'm going to move it down here, out of the way. Okay. Don't forget, I also have a nice chart over here that shows me the line fit plot. Now, if I want, I can go ahead, and the authors say that, go ahead, and we'll click in here, we'll click design, we'll click layout, pardon me, format, it's layout, I always forget. And we can add the chart title, the axis titles, and so forth. The legends, all we want to do. Okay, so I'm going to save this to my desktop. Okay, and I'm going to put it up here in my desktop. I'm going to call it Karma Digital Q, and I'm going to put case 9. And I'm done. Okay, and that will do this supplemental. I may do one more. I'll see how long this one is. And I'm going to stop the share. And then